You're right. You're right. Okay. Next up, we have Brendan Richards here to talk to us about Docker for .NET developers. Please welcome Brendan.
Thank you. I'll start by introducing myself. My name is Brendan Richards, and I'm a lead engineer at Xenix. So that means I spend most of my time working for clients. I'm a consultant, talking to them about their code, usually developing in some form of .NET or JavaScript. And also, Xenix is very much focused on Azure. About 20 years ago, I moved from the UK to Australia. And when I did that, I kind of moved from working mostly in Java to working mostly in .NET, and actually working mostly in Linux to working with Microsoft and Windows. But over the years, you're seeing much more Linux around for Microsoft software. So I think I've got a bit of a kind of head start on some of that story on how to get .NET code working in Linux. So I'm hoping to share some of those insights with you today. So let's start with a quick introduction to what a container is. And the best way to explain what a container is to compare it to a virtual machine. Lots of people have used virtual machines like a VMware or Hyper-V. And what you do with a virtual machine is you start a virtual machine and you load a complete operating system inside. So a virtual machine virtualizes the hardware of the computer, and you put a guest operating system on top, and then you install software on top of that. Well, with a container, it's much less. You actually share quite a lot of the underlying machine with the container, and so it's an isolated runtime that you just add libraries and your app on top. So rather than virtualizing the whole thing, you've just got this packet of isolated software with some libraries on top and some of the system being shared. So that means that containers are not as isolated as a virtual machine. Virtual machines are much safer if you want to run something in isolation, but containers are much smaller, faster, and can run many more in a smaller space. So one great place to put containers is the cloud. And look how happy that little icon there is called Moby Doc. He loves it up there. But this is not a talk about putting containers in the cloud, because there's lots of talks about putting containers in the cloud. And putting containers in the cloud is a very good place to put them. This is a talk about running containers on my computer, because I'm a developer. I want to run something on my computer first, because on my computer, I've got control, I can poke it, I can play with it. Once I get it working the way I like on my computer, then I can think about putting it in the cloud. So a quick introduction of what I'm going to cover today. First off, we're going to start where everyone should start, getting started. How do we install and run Docker on our systems? We're then going to look at containerized project dependencies. So I want to run a project, and that project's got dependencies. Let's put those dependencies in a container and look at the benefits of doing that. Then I'm going to look at building a containerized .NET application. I'm going to look at Docker Compose, which is an orchestration framework for running multiple containers with one command. And finally, we're going to look at Docker development environments. I'm going to explain what I mean by that as we go along. But we're going to start with getting started. And one thing I'm going to keep coming back to throughout this talk is Docker is a Linux technology. So the best way to learn Docker and be effective with Docker is to pick up a little bit of Linux, a little bit of shell scripting as you go. So I'm going to keep coming back and showing you a couple of things. The great thing about Linux skills and a little bit of shell script is a little bit goes a long way. If you learned something 20 years ago, it probably still works exactly the same way today. So it's a worthwhile skill to have, and you'll find that it'll ease your adoption of Docker if you just pick up a few things. Not a lot, but hopefully you'll walk away with a few things that are going to help you. Well, let's start by getting it installed. If you are working on a Linux machine, you can install Docker with a single command. It's the most natural thing to do in the world. Now, obviously, if you have any self-respect, there's no way you'd be running with a default console like that. First, you've got to install omyzsh, get some nice rainbow colors, get a really nice command prompt there. You need to install an override to your ls commands. You get lovely little icons against all your files. But once you've done that, you're good to go, and you can install Docker with a single command. In it goes, you're ready to go. But if you're inside Windows or Mac, you've got a bit more work to do, because Docker runs natively on top of Linux. To run it anywhere else, you've got to do some virtualization. And this is what it looks like on Windows. So we're looking on the right-hand side here. And we start with Hyper-V. So Hyper-V is the virtualization framework that you use to run Docker. And the latest versions of Docker run on something called WSL, Windows Subsystem for Linux 2. So what Windows Subsystem for Linux is a really low-level driver you install. And on top of that, it can bootstrap a Linux kernel. What's great about WSL2 is it's fairly fast, and the kernel for Linux that you bootstrap on that is byte for byte the same kernel as anything else. So WSL1 had to have a special kernel to kind of then compile special versions of Linux for it. WSL2 is completely binary compatible. In fact, it's so binary compatible that you can run the same kernel as any of the other distributions, and you can just run Docker on top. Then with Docker running on top of that kernel, you can then run Docker Desktop. It's a Windows application, and that will talk to Docker, and you get the ability to run Docker containers on Windows. There is one small issue, though, with using Docker Desktop, and that is Docker Desktop is not free. The whole of the Docker stack is free. The Docker runtimes running Docker on Linux is free, but Docker Desktop is not free. There's a couple of loop causes there. It's free for education and learning, which is why I'm using it without paying for it today. It's free for personal use and free for small projects. But if you're going to start using it properly, then you need to pay for a license. Licenses are not that expensive, but it is a cost to negotiate. When I first saw this, I went, well, that's crazy. Like, the Docker system's amazing. That's the really cool bit. That's all free. So why don't I look into how can we run it without installing Docker Desktop? And yes, it is possible to run Docker on WSL directly without Docker Desktop. So you install WSL by self, get a Linux kernel running, get a Linux installation running, and then put Docker on top. And that works fine, but that there's some other tools you can then use on top with that. You can install things like the Docker extension Visual Studio Code. That gives you a lot of the user interface you would have got in Docker Desktop. But it's not quite that easy. Docker Desktop does do quite a few things for you. First of all, it installs that stack on the right-hand side there for you, so it's much easier to do. Then there's a lot going on in that arrow there. So that arrow between Docker Desktop and Docker means you've set up a local copy on Windows of the Docker runtime that can talk to Docker running on your WSL. And it's on top of that that all the other tooling you want to use runs. So if you want to use the Docker plugins for Visual Studio Code, you want to use the Docker plugins for Rider or the Docker plugins for anything else, it's that arrow that's making that happen for you. Now, it's possible to make the connection straight from that tooling to Docker, but it's much more complicated. You've got to mess around with setting up sockets and stuff like that. So for most people, it's just going to be easier just to use Docker Desktop and pay the money. What you can do if you really don't want to pay the money, you can use Docker on WSL, but you don't get those GUI tools. You have to just use it all through the command line. One other thing that I like to do, that's not required, but how I like to run Docker, is if I go to WSL and call the set default command and actually install a full version of Linux as my WSL. And the full version of Linux I like using is Ubuntu, mostly because it's the most popular, and I don't want a bleeding edge one that's going to break every now and then. I want to just have it working, be stable. And so that's what I do. So I just go WSL set default Ubuntu, and that means if I want to go to a terminal and run some Docker commands in a terminal, I've got a full version of Linux to run it on top, or I can go to the Docker command in Windows, and it all kind of works seamlessly. It's the same Docker. So let's start by running some containers. So the very first command I'm going to run is Docker, and that's the Docker command. Let's type docker -- help. So Docker is like most modern CLI tools. It's got a pretty well set out help. I am not going to run through all these commands. There's lots of them. I'm just going to show you the ones you need to get started. But if you want to find out a bit more about a command, just go Docker command name, then -- help. You'll see all you need to know. What we're going to do, though, is we're going to run our very first container. And I'm going to call Docker. It's going to happen a lot today. Run hello-world. And away it goes. So what's it doing now? Well, I've given it the name, and the name I've given it is the name of an image. And it looks and finds I don't have that image locally. So we'll go to a Docker repository, Docker Hub, and I'll look for that image. It finds that image, downloads that image, and then starts to run a container based on that image. It then runs that container. So now in that isolated process, it's going to run a little bit, and all that does is the program it runs just prints out the stuff you see on the screen. It's a little kind of hello world Docker works. I'm going to do one more thing. I'm going to run exactly the same command again. This time you see it's much faster because it didn't have to go and fetch the image, didn't have to work with it, it just created it. But I'm going to show you one issue with what I've just done. And to do that, I'm going to go to Visual Studio Code. And I'm going to go to this Docker extension. And you can see in my list of containers, I've got 2 containers, both called Hello World. So what I want you to take away from here is the Docker run creates a new container. If an existing one's already there, it'll create a second one. And in fact, it generates some weird names there just to give you a usable name that you can type. What I can also do is go Docker run and give it a name. My hello world. Let's get there. And it'll run the same thing again. And this time we've got another copy of hello world and it's got a name. And if I repeat that command, it's going to not let me because I've already created one with that name. It's got an error. What I want you to take away from this experience is that these things are cheap and throw away. There's a concept of kettle not pets. When you create a container, it's not the container that's valuable. You don't want to do too much to the container. That means you have to look after it. You should change the recipe for the container. Containers you create, you throw away. In fact, they're so throw away, there's a switch for a Docker command, which is -rm, which means get this image, create a container, run the container, and immediately throw it away. It's a throwaway thing. Go and do some work and then get rid of yourself. And that'll do the work and away you go. Let's clean up some of those containers. Well, that's not an amazing container. That's a container that exists just to do that one thing and tell you that container itself is working. Let's do something a bit more useful with a container. And what we're going to do is we are going to, how about we install something that runs a service? Now, one possible service is a web server. There's a really popular web server called Nginx. So let's go ahead and create an Nginx server. So I can go Docker run -name my Nginx. And the name of the container is Nginx. Now, what I want to do here is this system is going to run a web service. So I want to be able to connect to that web service. And to do that, I need to raise a connection from my local machine through to the Docker container. So to do that, there's a switch called -p, which at first I thought was for ports, but actually it's for publish, and it's for publishing a port. Now, for a long time, I kept on getting which way around to put these back to front, but I'm going to set up, so 8080 on my local machine is going to get mapped up to port 80 inside the container. And if I run that, it's going. You can see it's running the thing. If I come here, if I now go to http://localhost 8080, that's it. I'm running a web service in my computer. If I hit stop, it's going to kill it. One more thing I could do is I could add the switch -d, and -d means run this as a service, no longer connect to the thing and keep it running. Run it as a background service and it will stay up. -d is for daemon, which is a popular Linux terminology for a service that you run. So that's why it's got a weird kind of name. -D it means run as a service, but it's D for daemon. Let me switch back across. Okay, so in summary, in running containers, docker run is the command that creates a container. My recommendation is give it a name if you don't want lots and lots of different copies of that container so that you can start it. Docker, I've just missed out that one. Actually, the docker start command will run an existing container. So I've had a container that I stopped, and then when I start it again, docker start will create that container. I'm going to show you one more thing next, which is if I want to, let's run this -D. Docker run -D nginx, give it a new name. Okay, so -D is run it as a service. It's now running in the background. But what do I do if I want to mess with that, want to see what it's doing, get into that system? I can see that it's running by going docker ps, or I can look for it in the tooling. If I want to log in and do something with it, all I can do is go docker exec. So docker exec will connect to that running container and run a command. And if I want to log in there and actually mess with it, I can say I want to connect to the, what name did I give it? Suspicious Wiles. Look at this, tab completion. And I'm going to run a command. Now, the command to run, if I want to kind of get in there and work with it, is bash or a similar shell program. So what happens now is, did that work? I didn't do that right. Docker exec, you see what I did there is I ran the bash program, but I wasn't connected to it, so it just immediately exited. What I need to do is do docker exec dash, I think it's -it. So that -it creates a terminal, makes it interactive. So I've connected the current shell program to the shell program inside the container, and now I can poke around. I'm now inside that container, and now you can see it's useful to mess around with your command prompt. You can see whether I'm inside something I've just logged into or my main system, and then I can just hit exit to go out. Okay, coming back to our slideshow. So far, we've looked at running a container, starting a container. Docker exec will let us run something. A very useful thing to run is bash, so we can log into a container. We also had a quick look at the VS Code extension for Docker. And a real important concept here is kettle not pets. A Docker running container is something that should be fairly throwaway. So let's go forward from there now. We can run containers. Let's run some useful containers. So what I'm going to look at is some project dependencies. Now, I do a lot of .NET programs, and the two most common dependencies I'm ever going to use with an application are Microsoft SQL Server, which is database, and Seek for running some log, some log collection. I also need a project that I'm going to actually try and run this with. So I do what I usually do if I need a quick test project, and I go to Jason Taylor's. He's right here asking questions. Clean architecture solution template. It's a good template to use here because it does have baked in database support, login support, enough stuff to be a real world example, not just running a hello world, because hello worlds always work. You want something that does something real. So the solution architecture template does enough real stuff to be a usable demo. So if I want to install SQL Server, well, there's one thing you can definitely do, and that's go to this web page and click on that little executable and install SQL Server on your machine. Time and time again, I've been bitten by this because installing SQL Server on your own computer does stuff to your computer that can never be undone. Doesn't matter how many times you run the uninstall, it will never completely leave. Plenty of projects I've been on where I've had to mess around with trying to install a slightly different version of SQL Server, getting stuck trying to map up different installs, different instance names. It can be painful. If we put SQL Server in a container, it means we can have a guaranteed unique edition of SQL Server for my project and have 4 or 5 different versions of SQL Server, the exact version I want, and have them completely isolated from each other. So how do we do that? Well, to find out about containers, a great place to look is this site called Docker Hub. So Docker Hub is a public repository of all kinds of containers. And if you search for Microsoft, you eventually find this one, Microsoft SQL Server Ubuntu-based images. So that sounds good. I like Ubuntu. Let's get ourselves one of these. So let's go ahead and install SQL Server. Now, as you go up with installing sort of bigger things with Docker, you start to realize that you're going to start running some bigger and bigger commands. It's .NET Run and quite a few switches. No, I don't like having to remember that much stuff. What I'd like to do is save it into a file. So I'm going to show you how to save some of these commands into a file. And to do that, we're going to create a shell script. So one way to create these shell scripts, I'm going to do the really easy way now. I'm going to browse, and my Windows subsystem for Linux has this little Linux thing here. So I can browse into that. I can see here's my Ubuntu install. I keep my stuff in, my name's Brendan, so my stuff is in home Brendan. And I've already created a little folder here called Docker with my Docker stuff in. And I can right click on this one here, and let's open it with code. So what's going on here is my Windows subsystem for Linux is running a Linux install. It's got some files there, but I can just browse to it from Windows. It's mapped up. I can open it from Windows Tools. And here is that file. I'm going to comment out this one for now and take a look at this one. So the exact switches you need to feed into a Docker run command to run a particular service really depends on that service. You need to go to that service's Docker Hub page, look at its README, and see what switches I need. In this case, SQL Server needs a couple of switches. It wants to know, bear with me, it wants to know that I accept the end user license agreement. So you've got to feed in an environment. And to do that is -E. So -E is to feed in an environment variable. And it wants to know my super secure password. Now, the two most popular passwords are password and 12345. So I've combined two of them to make the best password ever. And here it is. I've also published the port. 1433 is the default port for SQL Server. I've also given it a name so I can refer to it. And here is the name of the image I'm going to use. There's one more thing I've done, and I've created this thing here, -V, and V is for volume. Because remember, containers are throwaway. But there's something in a database that isn't throwaway, and that's the data. I don't want to lose all my data every time I've got a tiny update to my container. So what we do is we create a volume, and we mount that volume to our locations. That's the location inside SQL Server where it keeps its data. And this is the location on my machine inside WSL. They're going to put that data. So let's go ahead and run that. Oh, a little bit more about, just one more thing about a shell script. There's nothing special about the .sh on the end here. Linux does not use the standard Microsoft way of putting an .exe or .bat. It means nothing to Linux. I've just put .sh out of convention. It's not what Linux understands. What Linux does understand is you can mark something as executable. If it's marked as executable and it's a text file, the first thing it does is it looks at this line here. And this line is generally referred to as a shebang. It's really helpful to keep track what you need to put there. And then this bit here is the path to the file or the program that's going to execute it. Now, if you want to write a PowerShell program, you can install PowerShell core, make that the path to the PowerShell, and bang, you can run a PowerShell program. If you want to run a Perl script, you make that the executable to Perl, and it'll interpret this as a Perl script. One more thing to show you, this at the end here just means continue the current line. So I've got one very long line broken up into multiple lines, and you've got some comments here as well. So let's go ahead and take a look at that. And I have done one thing deliberately here. is if I ran this with a -D switch, which would be the default when I run it as a server, it would run, and then if something goes wrong, it would immediately exit, and I would look and I would see there's no container running without knowing why. So if I want to debug why something's not running, what you can do is the first time you run it with this -IT switch so it runs interactively, prints out what it's doing. If you see it get to the end, then go, right, that works fine. Now I can run it with -D. So you can see I've got my little MSSQL script there. Now, one thing that trips up a lot of Windows users when they go near Linux is the current folder you're in isn't added to your path. So if you want to run the script, you've got to start it with // which is the kind of path to where I am, and then type it. Let's go ahead and run it. It's already got a name, so I'm going to just delete the one that's there. There it is. And it's given me some errors. And in this case, the error is it couldn't find that file. It couldn't map that data directory. So I'm going to go into MSSQL. I'm going to delete the data that's there. Can you recognize that? Yeah, it says no. So put sudo do the thing, and it'll do it. Super user do. All right, so we've got no data there. I'm going to create a folder for data. Now, this is a bit of a pain, isn't it? I've got to create this folder that I'm trying to map to. We'll get there, and I'm going to show it so everyone can write to it. Don't need to remember this because I'm going to show you a better way soon. So yeah, that's what I mean. Thank you. Sudo. All right, sorry about that. I'm going to cut this bit out. All right, so I've got a data. Let's run this again. That's right. Already in use because I've tried to create it. I've got to delete it again. Now it's running. It's trying to create my database. And at the end, it's giving me a shutdown. So this is how you can find problems. And what it's telling me is it's unable to set the administrator password. Password validation failed. So the key thing I'm trying to show you here is that -IT, when you first run it, means you get this spool of text and you can see the error. Let's go and fix that up and go to the other one. Okay, so first of all, in this one, I have given it a much better password. No one's going to hack that now. It's got a P at the front in capital letters, and it's got a bang on the end. That's going to meet all my requirements, so we're good to go. The other thing that's changed here is instead of messing around trying to make this work with a folder that's on my system, instead, I can just put a name here. And this does something quite interesting. This creates what's called a data container. So it creates one more container that doesn't run anything. It just has a spot to put some data in, and it puts that in its own container. So now I've got a place to store this data. It's not on my system anymore. It's just a place I can put files in and map it up to this place. So let's go ahead and run that one. You'll probably need to delete. So let's run that one. And that is now running. Now, if we want to connect to that, how about we use SQL Server? Server Management Studio. Up we go. And we connect to localhost. We put in our super secure password. No one knows what it is because it was so long and complicated. And there we are. We can now use that database is now running inside that container, but I can use it just like I use any other database. It's ready to go. I can connect anything to it. I'm going to show you one more container, and that is, I'm going to show it to you here, my one for Seek. And once again, to work out exactly what you need to feed in here, you need to look at the README file for that particular container. And for this container, I'm giving it the name Seek. I'm giving it a /d to run it as a server, accepting end user licenses, accepting the EULA. I've set up another volume, Seek data, a couple more port maps. But there's something slightly interesting here. Seek is actually better configured than SQL Server because what Seek wants you to do is feed in a hash of your password. So you don't have your password just readable. If you go to the Docker properties and see the environment variables you fed in, you can see your password back. So it wants me to encrypt my password before I send it in. But how am I going to encrypt my password? So what Seek did is they came up with this little trick where, well, if you run the Seek container with config hash on the end, I will just generate the password and print it out. So if I go to Docker run that container, get it to print the password, and then immediately kill myself, then I can get my password out. And I put that in this property, ph, feed it in here. And so once again, the throwaway nature of Docker containers is I'm running a container here just to run one command, get my password hashed, and then later on I'm starting the container again with a full setup configuration, so it will actually go and run itself. So in summary on project dependencies, we can run project dependencies inside containers. It's a great place to do them. And I had a bit of demo where I was going to start up an application and show it. Let's just do that. Let's actually start it up now. I changed my mind. So now those dependencies are running. Let's make sure they are running. If I go to here, I should see I've got a database running. I can kill Nginx. I don't have Seek running because I didn't start it. So let's do that. I've got Seek running. So now I can go to my application. This is Jason Taylor's clean architecture template. He's done many, many good talks on this. But I'm going to go here. I'm going to make sure my connection string is pointed to localhost because that's what I've set up. And I've set up the database, set Seek, localhost 5341. Database is localhost 1433. I can go ahead and run Jason Taylor's clean architecture project. It will build. And this is a pretty useful sort of test project. It's got a .NET backend. It's got an Angular front end. It's using the SPA proxy service here. So it's going to kick off an ng serve to run the Angular kind of the dev server and the .NET backend server side by side. And there it is running my clean architecture template. It's also got the ability to log in. It's got some usernames and passwords preset, so I can log in. I can go and see my to-do lists. Off we go. Let's go ahead and kill this. Actually, I think it just killed itself when I hit close in the browser. That's quite clever, isn't it? I like that. So let's continue the slideshow. So far we've looked at putting dependencies in containers. It means we don't have to install those dependencies directly in our host computer. We can have different versions, different unique setups per project. Use volumes for the data you want to persist because containers should be thrown away. If you want to save some data, mount them as a volume. And we've seen that mounting as a volume container is way better than trying to mount as a volume to your computer. And that's a feature that's quite new. So a year ago, I was playing with Docker and I was messing around with volumes a lot. Now I found it much easier to put in a name and it will sort out and make a volume for you. So that's fantastic. And a little bit of shell script goes a long way. So if you want to be able to save those switches so you can remember them. I'm not going to type in 5 lines of Docker start every time. So do that. If you really can't get on with shell scripts, what you can do is install PowerShell, and PowerShell can run on Linux, and you set it up slightly differently. And the way to go, just change that first line of your shell script, and you can run PowerShell scripts from inside Linux. So the next thing we're going to do is jump a little sideways and look at how to make a containerized .NET app. So we're going to take a look at a web application. I decided to pick a pretty bog standard ASP.NET Core web app, but I ticked this little box here, enable Docker, and then away I went. So let's take a look what that looks like. I'm going to go and open up this project. Going to open up. And I've done very little to this project because the reason I'm opening this project is just to show you this. This is what Microsoft gives you, or the templates give you, when you say, I want to create a Docker file for my template. And I'm going to run through what a Docker file is and what's in here. So a Docker file is the recipe for making a Docker image. So a container is an instance of a running image. The image is what actually says what files are in there. And most Docker files kind of look like this. They always start with a from. You start with an existing image that you build on. And then you have a series of commands that build up the stuff you're adding to that image to make it your image. Now, this one's slightly interesting because it actually has 2 from areas. This is a very common kind of setup for Docker containers, because what we've got is, in order to build our project, we need the full SDK installed. We need all the SDK tools. We need to be able to compile. We need to be able to run. But in order to have a container at the end that we can use, we don't need the full SDK. We just need the .NET runtime. If we take a pre-compiled .NET application, put it on top of the runtime, it will just run that application. So we don't need the full toolkit. So what we do is first we grab the SDK image, then we copy just our project file across to it, and we call .NET restore. Now later on, we're going to run .NET build. And .NET build will run .NET restore for us anyway. So why do we do it in these 2 steps? Well, if our dependencies haven't changed, .NET restore will do a work, and the outcome of every image or every operation that changes the image is a new image. So if this stuff hasn't changed, we can save a lot of time not running .NET restore every single time we build that image. So this will create an intermediate image here that has all those dependencies in place, so all your NuGet packages. And then if all we do is change the source files here, then all it has to do next time we build is run this bit, and it will cache that step. So that's why we do it that way. This eventually runs .NET publish. Here it is. Yeah, it runs .NET publish and gives us some files in that publish. Then we take our base, which just has a .NET runtime, and we push it through to our application. And what we end up with is a container that contains the .NET runtime, the app we've just built, and the commands that says when this container starts, run .NET, the name of my app. What you can see at the top here is a little bit of warning kind of comments here, because what Visual Studio does to interpret that isn't just run this as is. In fact, if you switch to release mode, absolutely, it runs this recipe exactly, gives you a published release. But it has this thing called container fast mode to make your dev experience a bit quicker. So what it does for that is it's kind of skips through all this stuff, grabs this image, grabs the output of your build, and will just mount this image with an app folder mounted to your local machine and bind it up. So it'll run Visual Studio on your machine, get just the target image, push them together, and kind of run it that way in this kind of hybrid approach. The reason it does that is to give you a really fast dev experience. So I'll show you that. We click Docker run, not Docker run. In fact, we just click build. And what it will do is it will do a quick build of that application. It will start the container. It also attaches a debugger to that container. And here it is, it's hit a breakpoint. If I continue that breakpoint, now it's got a full debugger. So what's happening now is .NET is running inside a container. It's got a debugger running, and that debugger is attached to Visual Studio. So I can breakpoint, I can go forward, back, I can continue. And there it is. So my application at this point is running inside of Docker, but it's not the full isolated container build. It's done the build on my machine, started the container, bumped them together and attached the debugger. So that works really, really well for the basic, here is my web app application. The problem is this Docker file is the same Docker file you get regardless of what's in your project. So if you take the SPA solution template, the SPA solution template needs Node in order to build. It's in debug mode, it does some very different things. It runs the ng serve. None of that works in this mode. So this default template is really good for building basic .NET projects. It's not so good for building the more complex projects, especially ones that use the SPA template. So we looked at Docker and Visual Studio. The first thing we saw was Docker files. The Docker file is a recipe for creating a container image. It says, start with this image, do these operations to put my stuff in it, and then you've got a new image you can work with. Visual Studio is great. It can debug your app running in a container. And the container fast mode system works well for simple projects, but it does some weird stuff that might not work for a complex project. And most importantly for me, does not work for the SPA templates. Now, if you do .NET new -- list, you see the SPA templates installed by default with .NET. So the default experience for .NET containers doesn't work with the default experience for .NET list of projects. And there's a bit of a hybrid mix going on there. We're editing stuff in a local PC. We're running dev containers. We're mounting stuff in. It's not really the default container experience. So that stuff's a little bit off for me and how that works. And that overcomplicating things actually makes things break sometimes. But let's have a look at the benefits of a containerized app. So if we have containerized our app, it means works on my machine equates to works in any container provider. To a point, it means all the dependencies are at the same versions. Obviously, if you've got connection strings, and 9 times out of 10 it is the connection string, you're still got to get your connection string right for wherever you're going. But it does mean you can make sure that the things that should work and test them. Another great experience here is you're running the same build process on your machine and in your SDLC tooling, your software development lifecycle, if using GitHub Actions or using Azure DevOps. So many times I've got a build that works perfectly, and then GitHub DevOps will pick it up. Azure DevOps or GitHub Action will pick it up and run it, and it'll fail to build. If you've got a containerized app, that happens way less because the build process that you run is exactly the same as the build process the tooling will run. It's also a good way to ship working software. We saw Seek there. So with that Seek image, I'm confident that Nick Blumhart, who made Seek, is confident that if I get that image and feed it to Docker, it's going to start. If I go and fetch the Docker executable, run it on my machine, there might be a reason that doesn't work. And so there's a whole bunch of support that the Seek have to provide to support people that are trying to run on their computer and their computer doesn't support it. There's something that's broken. Where in a container, is way more likely to just work. And what you get out from that build of a containerized app is cloud ready. It's ready to go to the cloud. You can put it in Azure container instances. You can put it in Google Cloud. It's ready to go. So next thing I'm going to show you is a demo around Docker Compose. So what we've looked at so far is we've looked at running some dependencies, and we've looked at running a containerized app. And before we ran a containerized app, we had to manually go in and make sure we started all those different containers. So Docker Compose is an orchestration framework. It's a way of setting up multiple containers to start at the same time. So let's take a look at that. Let's go back to Visual Studio. I'm going to open up this one now. Okay, so this is a copy of the Clean Architecture Solution template, and I've turned on Docker, and I've turned on Docker Compose, and I get these few files here. So I'm going to look at this one. So Docker Compose is a YAML file, and I'm not a big fan of YAML, but I can see it's got its uses here. And what I set up is a series of services. So I've got this service called Web UI, and this one's got an image name, but it's actually telling it to build a Docker file. And that Docker file there is the same Docker file you just seen. It's a Docker file that you use to create a .NET application. We've also got another one here, and this one just says, here's an image, and it's an existing image. I'm not saying to build it, I'm just saying to get that image. And what I'm feeding in here are all the switches I would have put into that run command. So this is how to run my container. I also give it a container name. Now this is really important because what the Docker Compose will do is not only does it run these containers together, it sets up networking between them. So if I give this container a name, in the networking, it will set up this machine to run with that name as its host. So if I want to connect something on this container to this container, my connection from my web app to my database, I just need to grab that name. So let's go ahead and do that. I will go and open up user secrets. I like this new setting, use secrets.json. It's a way of sending in user-only secrets to your thing. And I'm going to just change the connection string so that it's CA, the name I've set. And I think that's all I need to do now. If I take this and switch this to Docker Compose, and I run, give it a few seconds to get going. So it's going to build my container. It's going to start up SQL Server. It's going to set up the, again, this has got an image for my SQL Server data. It's going to bring it all up. It's going to run it. And there were build errors. So what it's complaining about here is it couldn't let me bind up port 1433. The reason it didn't let me do that is because I was already running SQL Server somewhere else. So I'll come in here and I'll make sure I stop this SQL Server and stop the things I want to run. So there we go, it's stopping. That's all stopped. I've stopped this copy as well. Let's run that again. And while that's running, I'll show you one more thing. And I've made a change here to the Docker file. Instead of running that as my base install, my build install, sorry, I'm grabbing a slightly different version that has the .NET SDK and Node installed. When it builds, it can run the Node bits and away it goes. So here it is. It's now compiled. It started up my application and my and my database in that one thing. So that's Docker Compose. Lets me run two things at the same time. But I fudged this slightly. When I ran it in release mode. The reason I did that is the thing I told you earlier, that whole weirdness with the tooling trying to run things side by side. It doesn't run the .ngserve that well. And so I've got to do a lot of work to get ngserve to work. But I'll come back to that and show you a better way of doing this fairly soon. Okay, so we looked at Docker Compose. So in Docker Compose, we can build, run, and configure multiple containers. We can save all the settings you'd passed to Docker run into these YAML files. It sets up networking between those containers in a useful way, and it gives us a way of setting up that volume configuration. So so far, we can set up some containers, we can run some containers, and we can run dependencies for those containers. But I was never quite happy with that setup of what Visual Studio is doing in dev mode of trying to run some code on my machine and some code in the container and trying to set up mapping between them. So what I'm going to look at is, can I use a container for my full development environment? Now, why would I want to do that? Well, software projects can get messy over time, especially when they're not being actively developed. So at some point, you've got an old project, hasn't been touched for a while, you come back to it, and all the versions of the dependencies are a bit out of date, and it starts to get to this point where it's quite fragile, and you get afraid to update it. Now, absolutely, that is technical debt and does need to be tackled at some point in the future. I'm not saying don't tackle technical debt, but you need to decide when you're going to take that technical debt on. It shouldn't be, I've got emergency fixes to come through this project that hasn't been touched in 3 weeks, but we have to get that fix in. That's not the time to update everything. Maybe you want to put in that hotfix. So being able to freeze the entire environment means you can go forward. There's also something where I've definitely been experienced places where I've got my system set up just right. I'm about to launch a project this week, and so we're in our final kind of sprint. I don't want to mess with what I've got installed on my computer in case I install something over here that's going to break my experience over there, and suddenly I'm going to miss a deadline. So definitely trying something out just because a new version has come out might break your important project. Plus, there's one thing I want to look at. There's a brand new version of Jason Taylor's version 7 Clean Architecture Solution template. It's just come out, but I'm afraid to install .NET 7. Actually, in real life, .NET 7 is fairly safe to install, but certainly I've experienced Node projects where I was definitely afraid and shouldn't update stuff. So what we're going to look at is, can I start working with newer versions of .NET without installing it on my machine, have it all inside a container? We've got some options. Obviously, a really easy option is we get an SDK image for what we want to do. We open the terminal and we learn to program in Vim. Totally fine. Everyone can do this. All you need to do is just learn 50,000 very, very odd and totally unintuitive command lines, such as you don't use Control-C for copy because Vim was invented before then. You've got to use Y for yank. So once you've learned all those and you put a big sort of spreadsheet on your wall and you learn it all into your head, then you can be very productive with Vim. Or maybe not. That was not a serious suggestion. So you've got the Visual Studio approach, which you've seen before, which you can run some of it in the image, some of it in your machine, but it doesn't really work. But there is a better way. And there's a better way offered by two systems. Both JetBrains Rider and VS Code have a better way. So let's start with JetBrains Rider. So JetBrains has this brand new beta feature called SSH. And what it does is it will use SSH as a secure shell. It's a standard way of talking to any Linux system and running a shell program in a secure way. So what it will do is it actually opens the SSH connection and connects to your running container or your running remote server. And it will actually install a cut down version of the IDE into that remote container and then sync it to your user interface. So you've got the user interface on your machine, the actual dev tools, the stuff that's analyzing your code, the stuff that's doing the work, all those kind of code complete stuff is running inside the container. And so you can then point your tools at the code in the container and develop that way. So what we need to achieve this is a container with our dev tools, .NET SDK, that's also running an SSH server. Now, there is no container out there that I know that does this already. So we're going to do what I call a container mashup. We'll show you how to do this. So what you do is you find a container that you want, .NET 7 SDK, perfect, that's the one I want to use. We want to use some other tools on top, so we find another container that has the other tool we want, and this one is the SSH. And what we do is we basically cut and paste the instructions here from one into the other, and then we end up with a container file. And let me show you what that looks like. This is remote development.
in a container locally on your machine, which is isolating all of your development stack for a particular project.
Yes, that's right. So it's on your machine using remote. The thing you're remoting to is a container on your machine. But yeah, like you're saying, you're isolating the stuff, which means you can run .NET 7, for example, without installing .NET 7 yourself. And I know we're running short on time, so I'm not going to show the full demo. I'm just going to show you what the container looks like. Okay, so what we've got basically is we start with the container for .NET 7, and then I just pasted in the instructions from what I found with a SSH one. And then from there, let's just run it. Then we run it. And I open up JetBrains now. And I clicked SSH. Here we go. I think it's still got the same thing here. Let's see if I can connect. Is it going to go? Here we go. So it starts JetBrains Gateway. Caps lock on. I have one more attempt at this, and if it doesn't go, I will move on. There you go. Upload worker Bernie, checking JDK, it's working. Come on, this one's a bit slow. This one's very slow. And the reason it's slow is it's quite a big install, JetBrains. JetBrains is quite a big IDE. So it's got to kind of get that big sort of Java program pushed across to your container. Got to get started, got to get it synced up, and so forth. Once it finally gets there,
Keep running the same container over and over again, it's faster.
yes, it gets quicker. Yeah. Once its stuff is installed, I think it's been a couple of days since I run this. So it's probably a newer version, and it's taking ages to kind of sync itself up. So I might leave that running in the background and move forward, because basically what you would have seen is it opens up a project, just a console project on. You could see how you could click through, run that project in .NET 7, and it's running .NET 7 without .NET 7 installed directly on my machine. Here we go, and it failed. Okay.
So when you create and run a container like that,
Yeah.
is it creating resources that sit there even after the container stops? And
Yes.
create another one that can just check and see if those resources have already been created and just use them.
Yes, yes. The question there was, when you create container, it does create resources, and cleaning up resources. It's not quite as bad as that. If you have 5 copies of your container, it's not 5 times the difference, because what it still installs is the diff between your images. So it's really efficient. But if you have a lot of containers, you are going to assign a lot of resources. So it's good now and then to come back and clean up all the images you've got cached. Just give it a general cleanup. And there's tools there to help you do that, identify the older ones and clean them out. So that was JetBrains, and when it works, it's fairly good, but it's not the best experience I've seen. As you've seen, I tried just log into one that had working before, and it failed, and it was slow. It took a long time. It's quite a big, unwieldy stuff to push in. It is a beta feature, so don't expect it to work. And it requires you have to go and set up secure shell to run inside your container, which is a bit of a faff. But it will work for any other machine that can run SSH, so any cloud system, any virtual machine. So it's quite powerful. And JetBrains is a pretty full-featured IDE. It's my IDE of choice. So all that power you've got of JetBrains is there for your containerized app. For .NET, you need to wire up to solution file to start properly. So you need to kind of get in there to the console, get your project set up. Once there's a solution file there, you can point JetBrains at it and it'll work. So it's still beta, it's not quite there yet. So let's move on from JetBrains to VS Code remote development. It's a very, very similar idea to the JetBrains one, in that you've got your local operating system, you run VS Code on that system, you've got your remote OS, which can be your container, you run VS Code server inside that container, and it syncs the two together. So it's running tooling inside your container to work with your source code and run stuff, and then syncing it across to the user interface on your host machine. So to do this, you install this plugin extension called Remote Development that actually brings in three. It brings in one for WSL, which lets you connect to stuff running in Windows subsystem for Linux. It brings in dev containers, so you can connect to a container that's running and sync that way. And it brings in remote SSH. So JetBrains just gives you the remote SSH one, and you have to mess around to set up your container to give you SSH, where the Visual Studio Code tools give you all three options. So let's take a look at that. So I'm going to show you a few things I've got set up here. So I went ahead and I made a .NET image that contains Node. So to do that, I started with .NET. I then looked around, found some instructions for Ubuntu and how to install Node, and basically fed in the apt-get commands required to install Node on top of any Unix system, run it. So I've now got an image with .NET and Node ready to go. And set that up to run. So I go docker run -t-t. Here's the name of it. I set up a volume, and the volume here now is where I'm going to keep my code to work on. And that's it. Notice that I haven't published any ports for this one. One thing I do have to do with this setup is something that Visual Studio does for you, is when you run your Docker containers through Visual Studio, it will do a little bit of work to set up your .NET dev certs. If you're running .NET inside a container not through Visual Studio, you have to do a little bit of work. You have to get into your container, run .NET dev certs to generate the dev certs, and then export the PFX file for your dev cert. And once you've done that, you've now put it on in a folder somewhere. You can then, from your computer, Docker CP lets you copy a file from your container to your machine. So you go into your container, you generate a certificate, you export the certificate, you copy it to your machine, then you right-click on it and go install PFX. And when you do that, you pick the trusted cert authorities and you're ready to go. And that works. I'm going to skip forward a bit now because I know it's getting late. So that works. You can run the Angular template. It runs the full thing. But let's go a little bit further forward and bring it all together. So we've now got the ability to run the full Angular template inside a container. So instead of having it hybrid, where we've got some stuff trying to run on my machine, some stuff in the container, we put the .NET SDK and Node in the container. We put all our code in the container. We run from inside the container. And that works because there's no weird stuff going on. It'll run the Node server. It'll run ngserve. It'll run your system and work. So the final thing I'm going to do is bring it all together, Docker Compose and a full container to run everything in. And to do that, I will take a look at this file here. Let's come here. So what I've done now is I've got here a file called dev environment. Let's just open this folder and open code. Yeah, I'll do. So I've got this Docker file. This Docker file starts with .NET 7. It's going to install Node. It's going to put in the clean architecture solution template for me, just some going to get a shortcut, and it's going to install the dev certs. They're ready to go. There's one more trick we do here, is we want to run this dev container from Docker Compose, want it to start and stay running. This little trick here means I'm going to feed in a command that never finishes. It's a tail program. Tail is look at this thing and spit out the result as it goes. But we're looking at this device called dev-no that never has anything for me to see. So this is a command that will never execute, which means never finish. It'll execute and never finish, which means it'll start this container and just sit there waiting. So with that in place now, I can then look at my Docker Compose file. In my Docker Compose, I've set up my dev environment, which is that Docker file, which is Visual Studio. The .NET SDK plus Node. I've also set up SQL Server, and I've set up Seek. And I think that's all we need to see. There's also this file called Docker Compose override, which I can use to override settings. I'm using this to feed in the relative connection strings for my application. So the database I've set up here and its path is now set up with a subsequent path here. So hopefully that means I can come here and run, let's see, the right place? No. It's a good question. I don't think so, because I deliberately gave everything new names. But we'll stop this one. But yes, if I had any names that clashed with something that was running, that would have been a problem. I believe I found and fixed it up, but I'm going to make sure by just stopping everything. Where am I? Oh, I see. I need to go into that. All right, so here's my project with a Docker Compose in it. If I go docker-compose up to bring up all the services and -d to do it all in the background. Let's see how that goes. So you see it's bringing up 3 containers, one containing my Seek, one containing SQL Server, and that's got different names that won't clash, and one containing my dev environment. And it looks like that's all running. So now I can come to Visual Studio Code, and this here, Remote Explorer, is how I can get to different containers. I can see I've got my dev environment here. So I click Attach. And you can see compared to JetBrains, this is almost instant. It's just thinking. There I am inside that container. I need to run something. So I'll go to Useful Docker for Developers. It's that one. It's there. It's Source. It's Web UI. I'll delete that for now. Okay, so this terminal is running inside the container. This tooling is running inside the container just with the user interface on my machine. If I go .NET, this is going to do let's CD there first, sorry. Web UI, .NET, run. It should do everything it does when it runs the Clean Architecture Solution template. So it's going to start the .NET program. It's going to start the ng server. It's all running inside the container. There's Node inside the container. There's .NET inside the container. So there's no kind of weird connecting things up. It just does exactly what it does if you were to run the Clean Architecture Solution template from any Linux machine. What it also does is it automatically detects and publishes all the ports, picks up, I've started an application on port 5000, so it asks me to open it. Okay, I click open in my browser. It's now launching the SBA proxy. That happened in the background, kicked off the SPA system to run. So now it's running an ng-serve, and there it is running. So now we've got our Clean Architecture Solution template. It's running inside the container. It's running the Node service inside the container. And so the most important thing about this now is the dev experience. Because it's running .NET and the .NET ng-serve, it's also running the watches. So if I come in here and just change a bit of text, Let that go through. You should see immediately that I've updated my code. So I've got a functioning application. I've got a functioning dev tool now. I'm running a .NET version or 7 version. And if I go to my local machine, and I go to .NET --list SDKs, you can see I do not have .NET 7 installed. So it's running .NET 7 completely inside the container. Okay. Let's go back to my slides. Okay, so what we looked at there is we brought it all together. We used a container to run our complete development environment, and we used Docker Compose to manage those dependencies and get them all in one containerized network, and everything works really well. And because we've got that Visual Studio tooling, we can still use an IDE to get into that container and make changes and work in real time. Now, there's more than one right answer here. We've seen how to make it work for the .NET Spa templates, but there's another way we could have gone. Like quite often, you have a different team working in your front end to your back end. So maybe you should have put separate containers, one for your Angular front end and one for your back end. That's fine. You can also do crazy shit like run Docker inside Docker inside Docker and go really Inception. So you have a build tool that is my entire Docker setup. It can go a bit too far. There's another right answer, and that is a project under the .NET project called Project Tie. So that's a developer tool with a similar goal around orchestrating multiple microservices. This is really good. It also packages up things, and it's kind of more focused for running stuff on your machine and then getting ready to turn into containers that you run in Kubernetes. So worth looking at, but it's still an early stage as a Project Tie. They say we're going to change stuff all the time, where Docker Compose is very much more fixed. Obviously, if you start talking about cloud deployment, there's way more technologies to look into. This isn't a talk about Docker in the cloud. This is a talk about Docker on my machine. So we looked at getting started. We installed and run Docker. We used Docker to containerize our project dependencies. We looked at how to build a containerized .NET app. We saw a Docker file, and we saw the benefits of making a container. But we also saw that Visual Studio does some weird stuff for us with containers. And I actually feel that a full Docker dev environment gives you a better experience than trying to use Visual Studio in its hybrid approach with Docker. We also looked at using Docker Compose to orchestrate running multiple containers and setting up the networking between them. We also, on the way, looked at a couple of Linuxy things. We looked at creating shell scripts. We didn't get to that one, so I'll take that one out. We looked at installing software, and a few times you saw popping up was that apt command. Depending on what flavor of Linux you're using, you always use some kind of package manager software to install software. And the thing you most likely to want to do with a container is install some extra dependency or an extra bit of software into it to make a container that has more stuff in it. We also had a quick look at SSH and how to get that running. What we did was what I call a container mashup, taking two Docker files, smashing them together, and making a Docker file that has two things in it. And finally, don't forget that sweet console blink. Get yourself my SSH and the PowerShell Power Level 10K fonts, and everyone can see what an amazing hacker you are. Thank you so much for watching. I know we've got a bit rough in the middle there, so I'm going to definitely optimize some of those areas of the talk. I've got to get it down to 45 minutes, which it was not today. So thank you for your patience. But all the code you've seen today is on my GitHub. Also, check out Jason Taylor's Clean Architecture Solution template. We had a brief look at it today, but there's some good stuff in there. And thank you.
Do you have any questions for Brendan? Anyone have any questions or something you want to ask? Can you repeat the questions for the screen?
Yeah, I'll repeat the questions for the screen. JK.
So how would you compare what you have right now for remote VS Code with, say, GitHub Workspaces?
Very good questions. The question was, how would I compare what we've just seen with something like GitHub Codespaces? There's a couple of things in this area, actually. There's GitHub Codespaces. Also, JetBrains. If you looked at the JetBrains screenshot, you saw a little logo below. They've got a very similar idea. So the idea of GitHub Codespaces and the JetBrains ones is it's containers for development or VMs for development that they host for you. So if I want to set up a perfect dev environment to work with, I just go in, give them some money, and they give me a remote system, and I can start working away. Now, sounds like a really great idea, really good idea for teams to share their stuff. But I'll give you the answer I gave you earlier, which is it's not on my computer. This talk, I like stuff to be on my computer where I have control over it. If it is very much a very compelling story to have a setup, a shared setup on a server somewhere. The whole team just goes, clicks here, and they open up the identical dev machine. So it is very much a good story. But I like to understand what's going on first before you give me something in the cloud that I then have to understand. If it doesn't work, I don't know why. Jason.
You can share all of that with the team, right? They can clone the repo, they can spin up the same container, and they can connect to it in the same way.
Absolutely. The question there was, with what I've just shown, you can share what I've done with the team, and the answer is yes. That's what our container repository is for. So you can take a container you just built and push it up to a shared repository. Other people can connect to that repository, get the same container down, and then we're all in exactly the same set of dependencies. There's no, oh, Node works for me, oh, it doesn't for me. I had the experience just 2 weeks ago where I had a perfectly working build, and a member of the team said, yeah, I've got problems building this Node application. It's not quite working for me. Can you try something out for me? I'm like, sure. All right, let's try clearing your Node modules. Let's try resetting your cache. Great. Now try building it. Thanks, you've broken it for me as well. We've all got to try and work out what it is. It's technical debt, has to be fixed, but now no one can build the application. Yes.
You mentioned you have data containers for SQL data before. What type of data access is there between those containers, and can you share that container with other containers as well?
So we asked about data containers. Yeah, I'm not 100% sure on the access. I know that it kind of does a lot of work for you. So if you feed in the right configuration, it will create. And you ask about sharing. I think you can, but more for reuse. I wouldn't create two containers that are trying to write to one container file. It's the same as you wouldn't have two computers trying to mount the same hard drive. It's going to be a pain. Yeah. No, it's not really a SAN kind of solution. It's not designed for having multiple containers sharing a volume. It's more like a virtual disk that you can mount. But it is very useful because if you want to upgrade your container, so you're on SQL Server version 19, you want to upgrade to 20, you can stop the 19 server, keep the volume, bring up the version 20 server, point at the database. It'll probably go, oh, this database was created with a slightly different version. I'll just update it, and away you go. So you can upgrade your containers, point them at the same, but wouldn't try and put two containers looking at one volume. Rohan. Yeah.
Check the documentation and see if they can share a volume, because they'll have a form file to figure out who has the right locker. It's a great way to experiment in like multi-server hosting inside Docker, because you can't have what Docker calls a service with many containers running behind it. So you get that high availability without needing to replicate it.
That was a great question. I'll try and repeat that for the recording, and that was, yes, you can sometimes share, but I'm going to say, but it's complicated is a good thing. You need to set up stuff. Yeah, it's individual containers have to understand that's what they're doing, and they have to sort out between themselves who's allowed to write at any one time. So it's a lot. It's not just, don't just smash two containers together. It has to be a container that's specifically designed to be sharing data with other containers. But you gave the example of Redis cache as one that can do it. Yeah, thanks. Thank you very much. Any more questions?
Okay, well, thank you very much, Brendan. That was very, very interesting. I really enjoyed that.
Thank you. I've got some optimizing to do now before DDD. I've got to really narrow that down. But that's always the way, though, isn't it?
It is. And evenings like this are a great chance to try and practice in presentations. You might be preparing for something else. So that leads me to another thing. We're always looking for presenters. So if you've got a hour-long, hour-and-a-half talk, if you've got a 20-minute talk that you might want to practice, feel free to reach out to Todd or I. We're on
You can reach out through the meetup group. We're on BrizDev Slack. We're on the Twitters. We're all over the place. So feel free to reach out to us if you want to present, because we're always interested in finding more presenters. I know that D2D Brisbane had, I think it was 113 talks submitted, which is a huge number of presentations, of which there were 22 voted in. So theoretically, there's going to be another 91 talks that people are ready to deliver, thinking of delivering. So this is a great way to practice your public speaking. It was a very welcoming and accepting place. So we're always happy to give feedback and not judge if you have any little problems along the way. So a huge thank you to Xenix tonight. A big thank you to Brendan and Mariki as well for talking. Both great presentations. Thanks to Xenix for sponsoring tonight. Thanks to Telstra Purple for giving us this room to use. And another thank we've got is JetBrains has been sponsoring us as well.
Oh,
so
yes.
now anyone who presents at the .NET user group in Brisbane gets a free personal subscription to JetBrains. So both Marique and Brendan, who have talked about the use of Rider tonight, so they've probably already got subscriptions, they both get given one of these. So if you want a subscription, you just need to talk. So,
are we going to give away some today, though?
Yeah.
We had some great questions today. So if you asked a question today and you would like a JetBrains license, then
and
we've got
have one.
Yeah, then we have a copy to give away.
Don't everyone jump at once?
Free shit.
Anyone who asks a question not got a JetBrains subscription.
Yeah, do it. Take one. Try it out.
You get one of their IDEs for free for 12 months, right? So it means you can try it out and see if you like it as much as myself and Brendan and a lot of other people we work with.
And JetBrains have an IDE for just about anything you want. Yeah. So they've got Rider for .NET, WebStorm for web. Data Group is one I've been using a bit as well as a data studio thing. They've got IDEs for everything. So it's a really good suite of products. I actually have the All Tools subscription just because I like them so much. So.
Mm-hmm. Who else asked the question would like a free thing?
Well, my question is, can I have to ask one?
Yay!